Hello and welcome. So last time I created this beefy power supply here with full wave rectification over here, and I had initially put a regulator on there, but I thought to myself, why just congest this board here, because I'm going to need 3 regulators, because I'm going to need 3 voltages. Well, 2 of them are going to be 12 volts, since there's 2 here, rails here, might as well just make use of them. And there's going to be a 7805 because it needs 5 volt out for the SIDBoomBox. Before continuing, I wish to say many thanks to those of you who support me. Passionate content creation is tough, and your support means more than you know. Please consider supporting me by hitting that like button. Also, do subscribe if you haven't done so, not forgetting that bell icon or you won't be notified. Also, don't forget that I'm on Patreon if you wish to support me there. And also follow me on Facebook, Twitter, SoundCloud and Flickr. So, we're going to do the regulator today. I'm going to build it on the breadboard because I've never built it before, so I'm going to do some testing and then I'm going to build the actual thing. Now what I'm going to use for the regulators is linear regulators, of course. I do not want to use switching regulators on an audio device because it just creates more noise. And the ones that I'm going to use are the LM338K. So let's get the circuit diagram here out. It's very simple, to be honest. It's an adjustable regulator. I got this directly from the data sheet. That's exactly how it's going to be. We're going to need to make 2 of these, for 2 outputs, and of course 7805, which is just really a basic circuit. So, I've done that lots of times. Built this on the breadboard, or I think I have anyway. Let's hope it's all good. I've gone through it again a couple of times. So it ends up looking like a spider. Speaking of which, there's one crawling around somewhere. Right, so I need, this is voltage in, V in, and this is V out, and I can adjust the variable resistor here. Right, so I've plugged this in here. To the power supply, which is at the moment 0 volts, and I've put the output to the multimeter here. So hopefully I'm going to increase the voltage. Something should show up. Oh, okay, 2.2 volts. 7 volts, 8 volts. What is set to? Because I can actually set this. Okay, now the input is 20 volts, right? No. If I'm right, I can adjust this so that it, oh, cool. So adjust so that it's maybe 13, 14 volts, because that's how much I'm wanting it. 13, 14 volts. Let's take the input down. Oh, it's working. So they work. So what I'm going to do is just build this on 2 regulators, actually 3, onto 1 single board. That's going to be the regulator board. So let's turn this off. Okay, so I've created one already, one part of the circuit, well, one of the regulators. You notice these little terminals, these screw terminals. I'm going to make this entire thing modular. So you can you can take the wires out and separate it, so forth. It's just in case there's something, goodness forbid, there's something in the future wrong with a part of it, I can just unscrew one part of it and just take it apart and fix that, so forth. So yeah, I'm gonna make it modular. That's gonna be the beauty of this thing. So let's put this back here, this big heavy thing, which means business. First of all, in the transformer video, I did mention the reason why I got the bigger, more powerful one is because the lower powered one was actually more expensive, and significantly more expensive. And I was, all this was not cheap. So, I was trying to save wherever I could. Let's test this. Basically, you have the input going into here, and the output going into here. So the input, I'm gonna set this at 20 volts. Okay, so the input is at 20 volts, that is at 18, and the output voltage you can just simply adjust. So like, make it maximum. So it's like 2 voltages below the actual voltage. You know, that's how much it will be. So there's 1 volt. Let's jump to freaking, okay, 3 volts. 5, 6, 7, 8, 9, 10, 11, 12. From the underneath, I'm gonna put a bolt in, and from the top, and that is actually this perfect size, which is by chance. You know, I got some of these for something else, and it turned out to be perfect for this. Obviously the tracks themselves are not going to be perfectly symmetrical, but I'll make them as nice as possible. But this part I want to look symmetrical. These TO3 transistors, or not transistors, TO3 cases, whether it's regulator or transistors, are freaking fat legs, so you gotta drill. Okay. Perfect. Fantastic. Because now that I built the first one, the second one is kind of, it's alright. Freaking trying to get one of these on. It's alright because it's, I could just copy the first one then, you know, rather than having to look through the schematic. Start with the capacitor, the pillow, the 100 nanofarad. Now the inner ones, then the inner pins of the terminal are both going to be ground, so I don't need to make another ground freaking thing, just join into this one here. As I said, the back side to this, the solder side to this, is obviously not going to be symmetrical exactly, and yeah, I don't want to be silly with it. So, okay, so solder while that's cooling. Let's solder the regulator into place. The other leg of the capacitor. Here, I just soldered it onto this. This is the ground. Now, of course, how this is configured, voltage in, V in of the regulator is on this side, and of course V in is not going to be on this side, is it? So it's, you know, you kind of make it symmetrical. Okay, now let's solder the variable resistor into place. Here we go. This one, join under here. That one under here. I'm really enjoying this actually. It's kind of, it's just really cool. I like. Right, okay, so what we're gonna do is we're gonna get this one, bring it down here, all the way across here, because don't get it too close to that one. Okay, so just yeah, my iron is a touch too hot for this actually. Should really lower the temperature. This annoying freaking resistor. Just tack it down so it shuts up. Stupid mess, you idiot. Okay. There we go. Okay, let's tack that down at least. Okay, so have we got everything done here? Yes, that goes to there. This goes to here, which goes all the way to the ground, that's fine. This goes to here, and goes to there, good. Resistor, resistor. Okay, the top half is actually done. So I just need to do the bottom part now. Okay, there's a terminal here. Forgot I put that in. Let's put this. Wait, what the freak is going on here? Yeah, okay, so the outer is going to be the positive. Okay, so now it begins this side of the circuit, which is basically 3 capacitors. I've chosen a 1 microfarad, a 47 microfarad, and a 100 microfarad. The reason why I've chosen these values is, well, first of all, the circuit specifies 1 microfarad. They tend to act as filters, you know, and since this is an audio circuit, yeah, it's gonna be an audio circuit, I want the most filtration possible. Okay, so that, yeah, let's just solder this down so we can tack the others down like this. Yep. Yep. Okay, so, right. Let's put this down here. Someone connected? Yeah, it's connected. Okay, so let's, I think that's done. That was very quick. Wasn't quick compared to the first one, because the first one I was doing it from the circuit diagram, the schematic. Do you know when I just clipped that? Do you know where the freak it landed? It landed right on my neck and it's going down my back. Oh my goodness, let's get this out. How can it land dead center on top of my freaking neck? That's crazy. And yes, I do close my eyes when I cut these. Okay, good. Now let's come out of this. Oh, this is looking nice. This is heavy now. It means business. It's just twisted into place. Right, all we need is that. Okay. The first TO3 package I used was a transistor, and it was the 2N3055 transistor. Okay, now that's done. Oops, darn it. Let me just kind of turn that a bit so I can adjust. Yeah, that's better. The thingy's on 20. The power, the input power. So let's turn this down. Oh, turning it up. Let's turn it down. Yeah, fantastic. It works, and it works beautifully. That's those regulators done. One thing that did not occur to me until now. I think I've subconsciously made this look like Johnny 5. That was not my intention, but it's Johnny 5. I'm gonna call this the Johnny 5 regulator board. That's a cool name, I think. Okay, so I did a bit of a mock fitting kind of thing to see if it, you know, fits beforehand. I did notice that, you know, this was a bit too long, so I decided to kind of just like cut off. How's it going? I decided to just cut off this because, you know, there was no way to fit it in here. Because I plan to put this, the input at the bottom and at the top. I'm going to put this here, just slot it here at the side. Just seems to be the perfect place for this. Here. So that's where the power regulators and everything will be at the side here. Oh, it looks nice. Kind of like it excites me all coming together. So yeah, I decided, I mean, this didn't fit here, it didn't fit anywhere, it literally it's nowhere. So I'll recycle this, I will use this for, you know, another part of the circuit, which will fit there. Now then, with the power, I'm gonna have to, I mean, that's the output of this, which needs to go into the input of that, you know, this is the two power rails. So this needs to go here. First of all, this stupid stump here, this post, I'm gonna just like slice that off because there's literally no reason for that to be there, at least not anymore. So yeah, literally no reason for that to be there. It was there previously for like mounting the circuit board on. Because what I've actually noticed is that I need to kind of save space a bit. So there is a lot of board here which is unnecessary. It's just a lot of boards. There's a lot of board here which is just like unused. There's no, as you can see, there's really nothing to the side of the board. So what I'm going to do is make some posts here, some terminal pins, plug some there, and then just connect these wires here, and then just cut this part of the board off, so at least it's like a little more. So I'll just, you know, I know it's not going to go exactly the plan is, but this is the whole point of a project, that you kind of, you improve things as you go along. Well, that's how I work anyway. And it's clear that I've worked differently than many others. I don't have my own way of, my own method of doing things. These are the original sliders. I intend to use them on this. Okay, so let's slot this in here and have a look at how this fits in. There's more space for PCBs and lower circuit boards. This looks ridiculous, I know, but rest assured I'm not shooting myself up with stuff. Good. Holes for stainless now. And that is all for today. The next video will be the regulator board build. So do subscribe and follow this project for more excitement to come. Also, don't forget to check out PCBWay if you're looking for custom PCBWay circuit building. I checked out their PCBs and found them to be of excellent quality, and I'm indeed considering them for a future project sometime. They appear to have a special offer right now. Orders for SMT prototypes are only $30, and judging by just how surprisingly fast the goodie box with their PCBs got to me, I know they have a fast service. So that is all for this video, but do subscribe and keep an eye out for the others in this series because this is going to be a huge project. Thanks so much for your likes. Do share with your friends and do leave your thoughts in the comments below. Don't forget to check out my other videos to subscribe for more. Many thanks to all my patrons for supporting my channel, especially to my huge supporters and top tier patrons: Electron Skip UK, Axel Dominator, Robert Minis, Rich Corbut, Bohan Wayne Mitchell, and Chris Sablensky. Do see the video descriptions below to check out my patrons' websites and YouTube channels. Adios!